Alright, don't forget the easiest way to tell a discontinuity is when the bottom of a fraction doesn't exist or you're trying to take the square root of negative. So here x equals 6 is the discontinuity. If you make x equals 6, the whole thing won't work. Here x equals 1, x equals 3, x equals 5. If you do either any of those, it won't work. Here x equals minus 2, x equals minus 3. If you do either of those, it won't work. Question 2, let it be that. So we've got two different functions depending on where we are. So when f equals 0, we're going to have to use this one. So we've got 1 plus 0 squared equals 1. Okay. Copy and complete these tables of value. So we're doing x and 1 minus x. So 1 minus negative 2, 3. 1 minus negative 1, 2. 1 minus 0, 1. 1 plus 0 squared, 1. 1 plus 1 squared, 2. 1 plus 2 squared, 5. It is continuous. 1 minus x equals 1 plus x squared when x equals 0. So because we got the same values when we subbed in x equals 0, like it's going to meet. If we were to sketch this then, it would look like, I'm not going to do it well. We've got 1 minus x, which is this line. We've got 1 plus x squared, which is this quadratic. So the graph that we're trying to sketch is actually just 1 minus x when we're less than 0, and then 1 plus x squared when we're going up. So it's like that. The domain and range, well, the domain, all real x. The range, though, you're not going to get less than 1. Okay, these ones, I'm not going to sketch them. I'm going to let you put them into GeoGebra. But let's find out if it's continuous. So 2 cubed is 8. 10 take 2. 8, yes, continuous. 3 the 2. 13 take 2 squared. Not continuous, because they had this random drop. 1 on 2. 1 take a quarter times 2. It was half. Half, yes, it's continuous. 2 take 2, which is 0. 2, not continuous. This one's gone weird. Okay, this one. No. Because -1 plus 1 equals 0, so not continuous here. But funnily enough, even though they've given to us like this is actually just 3 lots of x plus 1 over x plus 1 equals 3. This is literally just, if I do a little x and y, it's literally just y equals 3 the whole way along, except we have a hole when x equals minus 1. So it looks like that. So the domain, x does not equal -1, the range, y equals 3. It's a very boring range, because 3, x plus 3 over x plus 1 equals 3, lots of x plus 1 over x plus 1 equals 3. That's why it looks like a straight line. Okay, this is an extension for students doing extension. This is the challenge question for them. So the zeros, none, because 1 over anything does not equal 0. Discontinuities, when cos x take 1 equals 0, so when the bottom equals 0, cos x equals 1, x equals, I forget that, 0 degrees, no. Yep, 0. And 180 would also give you that as well, would it? No, it wouldn't. 360. Okay, zeros. Zeros is when the whole thing comes out of 0. This one can come out of 0 if the top equals 0. Cos x plus sine x equals 0. Cos x equals minus sine x. So that's going to happen at 135 degrees to 25 degrees. And discontinuities, when the bottom line equals 0, so that's when cos equals sine, that's only at 45 degrees. They both come out as 1 on root 2. This one, top line, the zeros, this is essentially the opposite of the other one. No. Can't even be bothered writing the word discontinuity. Yes, I can. There we go. On to 8L. State whether it's continuous at x equals 0 and x equals 2 and whether it is differentiable there. So x equals 0 is there, 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 there. This is continuous. This is continuous at x equals 0. This is not continuous at x equals 0. It stops right there. And again, this is not continuous. If they're not continuous straight away, they're not differentiable. If they're continuous, yeah, they're differentiable. Now let's look at x equals 2. Okay, so for question A, it's not continuous at x equals 2. Automatically means it's not differentiable. This one, it is continuous. It does go up and keep going along. But it's not differentiable. It has such a hard drop. Like the gradient just here is not the gradient, sorry, I should do this. Just here is not the same as the gradient there. Okay, this one is continuous and differentiable. Look at it, it's nice and smooth, isn't it? And this one, it is continuous, but it's not differentiable for the same reasons as above. Sketch this. All right, but I'm doing a rough job. So at x, the graph of x squared looks like that. The graph of 2x take 1 looks like that. I don't know if that is a gradient, a tangent. Let's see if it's continuous or not. X squared is 1. 2x take 1 is also 1. Yes, continuous. Oh, I forgot to say that this actual function then, once we put those two together, looks like, and then it just kind of goes up as a straight line. Pretend I drew it better. Well, this one's kind of obvious because we're differentiating. Ah, I was right, there is a tangent. Nice. So at x equals 1, f dash x squared came out the same as f dash 2x take 1. Mathematically, I've written that incorrectly. The derivative of that equals the derivative of that, which came out as just 1. So that's why there is a tangent, because the gradients were exactly the same. Test each function for continuity at x equals 1. Check for differentiability at x equals 1. Okay, and I'm not going to sketch the graph. So at x equals 1, 1 plus 1 squared equals 2. 4 times 1 take 2 equals 2, therefore continuous. F dash x is going to be 2x plus 1, or 4. So we're going to have 2 times 1 plus 1 equals 4, or 4, which is 4. They're the same, so therefore it's differentiable. So the actual functions themselves came out the same at x equals 1. Their derivatives came out the same as at x equals 1, so it's continuous and differentiable. 3 take 2 times 1 is 1. 1 over 1 equals 1, therefore continuous. Now let's do the derivatives. Three take 2x is going to end up as negative 2. 1 over x becomes negative 1 over x squared. We've got negative 2, we've got So these came out different, so it's not differentiable. We'd have something weird going on. Okay, this one, 2 take 1 squared is 1, 1 take 2 squared is 1, so it's continuous. F dash x, on the other hand, negative 2x, or 2x take 2. When x equals 1, we've got negative 2 times 1, which is negative 2. 2 times 1 take 2, negative 2. So it's continuous and differentiable. This one, x equals 1, we've got 1 take 1 cubed is 0. 1 take 1 squared is 0, therefore it's continuous. Now let's do f dash x. We've got 3 lots of x take 1 squared. We've got 2 lots of x take 1 to the 1. When x equals 1, we've got 3 times 1 take 1 squared, which is 0. We've got 2 times 1 take 1, which is 0. So they're the same, therefore it's differentiable. They're not too bad. Okay, let's do this one. Do I really have to sketch this? So when x equals minus 2, I've got the square root. I'm going to do a table of values. I'm so tired. So I've got root 1 take negative 2 plus 1 squared, 0. Sub in negative 1. Sub in 0. Sub in 1. Sub in 1, but this 1 changes to a minus. Sub in 2. So it's gonna look like that. I don't know why they wanted us to sketch that. It looks like a bum. That was a weird question. Why did I say that? All right, extension. You should be able to do this easily. I've only asked you to do A and C. Now, don't forget, when we're sketching absolute value functions, we sketch the positive of it. X plus 2 is just going to look like that. And it would also keep going down here, but every time it goes down below the x-axis, you reflect it. So it's continuous everywhere. But when it comes out as 0, it's not differentiable, because you've got this sharp thing going on. This one, that is the same as x take 3, x take 1. So that's a quadratic. It's would normally be like that, but because it's the absolute value one, it comes down and it reflects and it goes back up. So it's continuous everywhere. But it's not differentiable. At the x-intercepts. I believe that's all we had to do. Yep.